Okay, welcome everyone to this afternoon's Safety and Resilience Committee meeting. We are live and recording, and I think, Alan, you were going to do a karakia for us to start today.
Thank you, Gary. My pleasure. I'll do that. Here we go.
Thank you.
Tuia ki runga, tuia ki raro, tuia ki waho, tuia ki roto, tuia ki te hiri tangata. Ka ronga te pō, ka ronga te au, haumie, huie.
Excellent. Thank you very much. Okay, we are underway. We have online Michelle Mifflin and we have Dr. Stacey, correct? Welcome. We have an apology from Councillor McCall for lateness. And I don't think we have any other apologies.
Alexa.
Oh, Alexa, sorry. Yes, we do have an apology from Alexa.
Kevin.
And
Oh,
Kevin.
sorry, using Kevin Malcolm.
Right. Okay. Can I have someone move that we accept those, please? Councillor Wilson, thank you. And Councillor Weir, thank you. All in favour?
Aye.
Against? It's carried, thank you. We have no public forum. Our agenda has been pretty much confirmed. Declarations of interest, just a reminder as usual. We don't have any presentations. We do have a presentation with the papers. And we open action committee, there's no current action, so we're on to our first paper, which is yes. We need to confirm the minutes of the previous meeting, the 10th of August. If everyone is happy with that. Okay, you'll move, thank you, Councillor Laws, and second, Councillor Sutton. Sorry, it's Councillor Robertson. All in favour?
Aye.
Against? It's carried, thank you. Right, paper number 1, 9.1, head of Wakatipu Natural Hazards Adaptation. So we've got 3 papers today, all quite technical papers, 240 odd pages, but some really interesting stuff. John Luke, welcome. Right. So for this paper, do you don't have other people online supporting this paper, do you? We're just the two of us.
Michelle Mifflin, Member of
Michelle
Engineering,
is
is there for any engineering related stuff, and then we have other staff here as well in attendance.
Great. Okay, I'll leave you to introduce the other staff, please, and then introduce the paper. Thank you.
Yeah. So just in terms of introduction, I think you've met everyone from previous meeting, but so we got Simon Robertson, team leader of the natural hazard analysis team, Jeremy McKenzie, natural hazard adaptation specialist, and Conroy, team leader, natural hazard adaptation, and Tim Van Moeder, senior natural hazard analyst in the team. Specifically for the first paper, the head of the lake, the author are Jamie, Ann, Tim, and myself. It's a very short sentence introduction. I'll take the paper as read, but it's an update to the committee around progress that's been made since the last update in August.
Right. Okay. Thank you. So we have all read the paper. Open it up for questions. Can no one think of a question? Councillor Somerville, thank you.
Look, I've just had a question about your the engagement, which I see a lot of effort is going into. I note in paragraph 22 that you've identified some groups who haven't had an active part in that engagement process. You note a gap has been in youth and families with young children. So I guess what was your plan for catching them next time?
Maybe I'll let Jamie respond to that one.
Yeah, so we can come up to Yeah, so as part of our future engagement planning, that's something that we're really considering and also talking with the community about how we can engage with those groups. We'll be informing that planning too, but specifically we've got the social impact assessment which is happening at the moment, and as part of that they're engaging with the school children and also going to the play group as well to try and capture some different people in the community too. And I'll be attending with the emergency management officers, which is noted in paragraph 36. So we've got going to the Glenorchy Community Fair to talk about emergency preparedness and resilience. So that's kind of going to where people are already at. So that's, yeah, those are some of the things that you're doing to address those.
Right, thank you.
Hugely important question, but I was curious around the on that figure one where you've got the like what is happening, what matters most, what can we do to make it happen, how is it working? Sort of mirrors the process for South Dunedin. I was just wondering if that was like now the sort of default framework that we work under, and if that was unique to us, or if that's like a national standard or something now.
Yeah, so those questions came from the 2017 Ministry for the Environment guidelines around coastal adaptation. Obviously, Glenorchy is not on the coast, but the principles apply for any adaptation work. So we are using those guidelines in different adaptation work program when relevant. And those are really good for long-term adaptation questions where we know the environment, things are changing, but we don't know exactly when things will happen or what will happen in detail. The guideline gives a really good framework to work with, similar to South Dunedin, we're applying the same. This version we have here, it's a kind of linear progression, but actually the guidelines talk about a cycle of decision. So that you have to think about this line repeating again in a few years' time.
So we are adopting that as a way of operating efficiently and consistent communication to community, and it represents New Zealand best practice at the minute.
Great, thank you. Any other questions?
Happy to move the two recommendations.
Great, thank you very much. Move Councillor Noon, second Councillor Weir. Okay, we'll open it for any further discussion. Councillor Somerville.
Thank you. I'm going back to the engagement again, and I'm really just to say how good it is to see the ORC building on its knowledge of community engagement. And I see you've specifically noted how you've drawn on the work of the South Dunedin Future Project, and you're doing this here through this Head of the Lake project. And I guess in future engagement, we'll have another model to be able to draw on. So I guess it's that. I think the ORC is doing a good job taking that engagement really seriously. And that example, for example, where you've identified, here are some groups we haven't seen. So what are we going to do about that? It's a really good thing to be doing. So congratulations to everyone who's been involved, and good learning for the future too.
I'd certainly echo that. I think the engagement that's been done to date, when you having been at those sessions, all the right people are there, the sheer number that are there. It was a wee bit disappointing, the numbers that came along, but the people who did come along were, I wouldn't say the right people, but they were ones who were engaged and they had a lot to offer. So that was really beneficial. And if we keep up that level, then certainly from our aspect or our side, I think we are certainly playing the part that we need to. Councillor Robertson.
I just think this is an example of where our council, but also I guess regional councils in general, but particularly ours, with the approach that we've taken here, is at its best really, when we're able to bring together technical information to work with communities and to be really proactive in planning together rather than just reactive, which gives, a lot of confidence to communities. We're together, we're holding hands right through this, we're not going away. and whatever the ultimate decisions are, we're there together. And I like the adaptive pathways approach too, which recognises that we are in a dynamic system. And we are working with people and we are working with the environment. Both of those are equally as important. And yeah, I just really, really like the approach that we're taking.
That's great. Thank you. Any other comments? Okay. Oh, well, keep up the good work, everyone. Thank you. It's got a wee way to go yet. And yeah, so I will put that motion then. All those in favour?
Aye.
Anyone against? No, it's carried. Thank you. Right, so we'll move on then to our second paper, which was 9.2, Otago Rain Radar. Gavin, Jean-Luc, you'll introduce the paper again, please.
Yeah, so the paper really is to update the committee on a significant development in terms of information that we can use in flood response, and that's coming from the weather radar that Met Service has installed in Otago in December 2020. So in December 2020, that was a major step for the region in terms of having access to data, and today is about what ORC has done with it to make it more operational from a flood response perspective. So the paper talks about the development, but also the limitation of that equipment, and recommend some improvement by having another device in the region. In order to present the technical aspect of how radar work, how we can derive rainfall information from that type of gear, I've got Dr. Sutherland Stacey online, who will give a presentation around the works. Basically, it's explaining how radar works in terms of trying to understand rainfall amounts, but also the limitation. And what is also a major development is what's called nowcasting. So the radar is looking to what's in the atmosphere and trying to estimate rain. But one use of that is to try to forecast potential rain for the next 1 hour or two. So Luke will cover also that aspect. And the idea of having Luke presenting is for you to ask any technical question you want and hear that from the expert. So I'll let Luke start the presentation.
Thanks very much, Jean-Luc. I'll share my screen. Bear with the technical aspect of it. Hang on.
Welcome, Luke.
Hello.
Maybe.
Possibly. You hope so. I'll try this one. See if we get a PowerPoint presentation. Share. All right, we do. There we go. Wonderful. So slideshow from beginning. There we go. Everyone can see that okay?
Great, thank you.
Wonderful. So I thought I'd just, Jean-Luc's done the introductions, but this is what I was hoping to cover in what's hopefully stays not too complicated. I've endeavoured to make this accessible, and I can respond to questions in more detail to these points if the committee requires some more information. Just here's a picture of the new radar that Met Service have installed with the assistance of central government to provide this information for Otago Regional Council. So it's a nice site, modern radar of the latest type that would be deployed anywhere in the world if a regional authority went out and got a new one. So it's a very nice piece of equipment from Met Service. So here we go. Here's the problem definition. And I think as a scientist working in a technological field, it's very important that we don't let our sort of technological or scientific specialty detract from what is in essence the problem. So before I talk about rain radar, I thought I'd talk about what we're actually trying to do in the first place, which essentially is measure how much rain falls everywhere in the region, with the view of using that for council's activities for civil defence and emergency management and planning. So in the simpler sense, that means we'd like to know over time, over as long a record as possible, how much rain would accumulate in a bucket in a given period of time throughout all the rain events that have happened in recent time that are relevant to the community. And that's really this sort of problem is, well, if I put out a bucket, a sophisticated, computerized, telemated bucket that can record all this information automatically, that's great. But I don't necessarily know how much would be accumulated just down the road in the next bucket, because rainfall is very intermittent in both space and time. And of course, we've seen that recently with events, not only in Otago, but also around the country. So the only way really is to go out and get another bucket and check how much rain falls in there. And therein lies the crux of the problem, is you just can't do this everywhere in a big region. So we're left with a sort of sparse record that isn't adequate for managing that natural hazard. So what's this part of the solution? Well, stepping one step closer to the technology, I thought it'd be kind of interesting to introduce radar in terms of echolocation. So there's a bat which emits a ultrasonic pulse, and they're well adapted to listen to the reflections of that pulse off their prey, and using that information they can locate things at distance. And that's basically how radar works. So, we're perhaps familiar with that for ships. There's a little circle there. The navigation radar for a ship, which of course was aircraft and ship navigation radar, were the first application of the technology. But as it turns out, you can use that for rainfall too. So here's another two examples of weather radar. There's the Auckland radar on top of the ranges just to the north of Auckland there, an older tower, which is soon going to be upgraded to have the equivalent technology that's available in the new Otago radar. And here on the right, here's an example of a research radar, which was operated by my research group at the University of Auckland when I was still there. So that's on a deployment in Australia, measuring actually not rain, but snow up in the hydropower catchments there. So that's what this equipment looks like. They can be all different sizes, and some of them can be packed up and moved about. Inside the radome, as it's called, is the equipment that is operated to generate rainfall measurements. It comprises of a computer to control the system, a transmitter which emits the pulse, much like a bat emits an ultrasonic pulse. Here we emit electromagnetic pulses at very high frequency. There's an antenna to direct that into the distance, and then a receiver, which is like the ears on the bat to hear what comes back and provide some information to go into the computer to build up the maps. And of course, the antenna is motorized, so just like a bat, it can scan around and look for things in different directions. So here's an example, just a conceptual example. There's some rain somewhere. The radar is scanning around and emitting pulses. Hopefully that animation comes through, the pulses go out, and reflections come back off the rain, and they're received by the radar antenna and digitized to create the data that we use to build up rainfall maps. The time that it takes for the pulse to go out and come back tells you how far away the rain is, and the intensity of the pulse tells you something about how much rain there is. So just play that animation again. There we go. So and that's done automatically by the computer and the motorized antenna, 24 hours a day, 7 days a week. Once that's all put together, hopefully the animation comes through. This is a topical radar map from the Auckland region. No doubt the date's familiar to everyone. So that information from the antenna and the computer is collated into these radar maps that most people in the country are now familiar with because they've been available for quite some time through the Met Service activities. And the instantaneous measurements of the rainfall can be accumulated up with appropriate data processing to provide these maps and, of course, the underlying data, which can be used in the regional council or local councils' modelling activities, for example, planning activities. So here's a map of the Otago region. And I've sort of flippantly put this label in not enough buckets. So the circle is a 100-kilometre range circle around the radar, which is a triangle there down near Dunedin. The dots within the circle are the rain gauges operated by Otago Regional Council. Of course, there's, I'll say, relatively few, perhaps compared to engineering guidelines, which you'll have no doubt read about in the report. So this is not an exceptional situation. The number of rain gauges is per square kilometre very similar to other regions around the country, but it does mean that you can have large areas which are not observed. So radar is helpful, but it isn't a complete solution, and it's not a perfect measurer of rainfall. So we'll press on. Oh, yes, there's some sort of statistics there. So it's not a direct measurement of the rain volume. Now, there's sort of two key limitations that I just thought I'll sort of just discuss them conceptually as they build up into the reasons that other recommendations are being made. So rain radar measures the reflection off raindrops. And in this sort of cartoon example of raindrops, they're all the same size and they're all uniform in shape. And if reality worked like that, then rain radar would work very well too, because the return off 2 raindrops would be twice as much as the return radar return off 1 raindrop, and away you'd go with the computer to add up that information. Unfortunately, that's not the case. In reality, you get raindrops of all different sizes. The small ones are circular, but as they get larger, they become more oblate. And that's because as they fall through the atmosphere, the force of the air pushing up on the underside of the raindrop causes it to deform. You get complex interacting processes like coalescence of raindrops where they hit each other and join together, and breakup of raindrops under the force of the air that they're falling through. What that means is you end up in any given volume of the atmosphere that's raining with a whole size distribution of raindrops. And that's a very unpredictable process. And so different types of weather result in different size distributions of raindrops. And all the raindrops of different shapes and sizes have different radar returns. So it becomes what we would say perhaps mathematically or from an observational science perspective becomes an ill-defined problem. So we don't actually have enough knowledge about the system we're trying to measure it perfectly. We don't know all the information about the raindrop size distributions, so we struggle to get a very accurate result from the rain radar alone. And there's a discussion, I think, in the paper about a gauge adjustment step, which some of you might have heard discussed, where we sort of try and correct these biases, but that in it is also not a perfect piece of science. So that's one of the limitations of rain radar, and that's the same everywhere, of course, around the world, because everywhere is subject to the same physical limitations. Now, a peculiar limitation to New Zealand is our challenging topography, not just from a natural hazards perspective, but it turns out from a rain radar perspective also. So here's a map of the rain radar coverage with the notional range, maximum range of the rain radars overlaid. These are white circles, 250 odd kilometre range rings. That's sort of fine. I mean, if you install a radar and you're out in the ocean, that is the range, but of course we've got all these topographical barriers in New Zealand. So it's a bit of a naive diagram. So we can have a look at a digital elevation model of the South Island. Here's an example for the worked analysis for the Otago radar there, the triangle in the center of that plot. Once again, I've drawn range rings around the radar. It's got a 100-kilometer range ring and a 250-kilometer range ring. And so the radar emits pulses of electromagnetic radiation in a straight line. They go out and come back, and then the dish scans around and emits more pulses and builds up a map in that manner. So you have to have line of sight, basically, to the thing you're interested in measuring. So here's a cross-section, AB, from the radar out to some maximum range that the equipment records to. And look, now that's fine for areas that aren't badly affected, well, aren't subject to large topographical variations. The blue line, the solid line, is the center of the radar beam at the lowest scanning elevation run operationally by Met Service. The dashed blue lines represent the beam width. So if there's any rain within that volume bounded by the two dashed lines, it will be detected by the radar. And the red line is the lowest elevation where there's line of sight. So the radar could be programmed to scan a bit lower down and measure things closer to the ground. So that's fine if you don't have much topography. There's another sort of limitation, which is, well, how deep, how far into the vertical does the atmospheric or the weather phenomena that you're interested in extend? So those range rings, 250 kilometers, are perfectly fine for tropical cyclones and real large scale weather events, because they're very, very deep. So it can be measured at 5,000 meters altitude, and you know something about the physical system. As the scale of the rain we're interested in measuring decreases from those very damaging events, and I mean, of course, there's very little chance of Otago experiencing an extratropical cyclone. So as we move into sort of the weather regimes that are more relevant to the Otago region, of course, what we find is the depth of those events decreases, and here's sort of the real problem is that when you get into more moderate rain, and particularly cold rain, which is it's a cold region of the country, the depth that occurs within is much shallower. So there's increasingly the chance to overshoot that rainfall, and what's referred to as overshooting, where the radar beam just doesn't intersect with the thing that you're interested in measuring. So just a further example of that, here's the radar's visibility to Queenstown. So that's indicated there with an arrow on the cross section. So again, from the radar across through to Queenstown and onwards over the Alps. And so here's another problem, which is beam blocking. So that's a complex topography, as we all know, in the South Island, and the lowest elevation scan is partially blocked by the intersecting topography, which means that, for example, above Queenstown, the radar really can't see below about 3,000 meters, and so that means it misses a lot of the precipitation processes that would be interested in capturing. Here's a map of the lowest observable altitude from the radar station. That's a physical limitation of the site. Perhaps I should have pointed out here we've projected, funny thing for a scientist to do, but we've made a flat Earth projection. So we pretend that the Earth's really flat, and we ascribe all the actual curvature of the Earth to the radar beam. So we sort of remap to have that radar beam appear to curve up. Actually, it goes out from the radar site, and it's actually the Earth's surface that drops away underneath. So that's just a peculiarity of the way that we draw these plots in this field. But the take-home message here is, look, if you're interested in measuring all the rain, you really need to be below 1,500 odd meters with your measurements, and that's just not possible because of terrain blocking from that site. And it's just that sort of the reality of that site selection. And look, this is a very complex topography to contemplate rain radar deployments within. And when you choose a rain radar site, you're sort of optimizing for a given budget, site access considerations, maintenance considerations, how hard it's going to be to build the structure. And if you sort of think back to the initial slide with the picture of the radar site, that the site's very accommodating, I suppose, to construction and maintenance activities. So it's a good site for rain radar observations to support the densest, or some of the dense population in the South Island, but in Otago, but perhaps not ideal for the regions closer to the Alps. I thought I might point out what happens in comparable topographies. Here's the Swiss Alps. This is another level of site engineering requirements. The actual radar inside the radome be very similar, but it's much more challenging to build a radar in a radar site to house the equipment in those conditions. But it is possible. Jean-Luc just touched on nowcasting. So assuming we have good radar observations down near the coast, for example, where the radar makes nice observations close to the ground, and we've got a reasonable gauge network to affect gauge adjustment processes. I've allowed myself a technical diagram. We have some idea of the rain within the limits of the observing system, current conditions. So they're sort of constrained. This could be sort of considered an accumulation plot, perhaps, for a particular location. So we have our observations up to now from the rain gauges and from the rain radar that give us some confidence into the current rainfall conditions. We'd like to know something a little bit into the future rain. So we can use a nowcasting piece of nowcasting software that has been developed by the Bureau of Meteorology and Meteo Suisse, based on some work actually that one of my current employees had undertaken earlier in his career. So we're quite lucky to have him to help us navigate those science aspects of the work. We can propagate that information forward for short periods of time to provide some very short-term estimates of future rainfall conditions. It's represented with an ensemble of possible future conditions. So we're not sure exactly the direction or the speed that the rain's traveling in, and we're not sure of the ultimate sort of evolutionary trajectory of the rain cells that we're interested in knowing something about. But we can sort of account for all that uncertainty within what's referred to as an ensemble. So in a computer, you simulate a large number of possible future rainfall scenarios based on your best estimate of the observations and the evolutionary characteristics of the rainfall at the current time. And so here we've got the 1 hour nowcast, so 1 hour into the future at this time. The mean, or the average nowcast, had this sort of cell tracking over the peninsula down there, and when we look at the observations, indeed that's what happens. So quick overview of the nowcasting sort of outputs that ORC will be working with. It has some limitations, so it doesn't know anything about physics or the topography. So it's not terrible, but it doesn't perfectly know the future either. And that's my presentation. I might just stop sharing so I can, if there's questions, I can pick up on visual cues, because I lose everyone when I'm sharing.
Cool. Okay, now that's really interesting. Thanks, Luke. So we do have some questions. Councillor Wilson.
Well, congratulations on having a presentation, which I think would be the first time I've ever had one that my husband will sit down and watch. He does love weather. That's really, really interesting. And you talked about a sparse record, and for some weather watchers are either in Wonderground or on the Met Service, the independent sites, although for rain gauges. is there a preferential, I mean, we've got a whole lot of catchment groups out there. I'm just wondering, is there a preferential way of getting data? There's other systems in place for rain gauging is what I'm trying to talk about, and building the predictive models. I'm just wondering, is there any preferred way that people can be recording what they are getting in the meantime?
I've perhaps can answer that from my perhaps more academic experience. I'm sure Jean-Luc could contribute in the operational council perspective. So during my time at university, we did a lot of field work in the central North Island, and I was certainly struck by the community's level of interest in rainfall processes, but also the systematic recording that particularly many of the rural members of the community undertake for very long time periods, frankly, with rain gauges on their farms. And so we couldn't really do any field work without the local farmer coming over and offering us his rainfall records or her rainfall records, which was quite neat. So to get that sort of passive engagement without seeking it is quite a neat thing in science. I think internationally there's a lot of interest in this sort of information that's been collected for a long period of time but hasn't been accessed or incorporated into engineering and science activities. A challenge, again, internationally around that is that all of the records will be in different formats and all of the equipment is different. So it can be quite hard to sort of reconcile that information.
So look, I was talking about those existing ones that are linked to the internet. And
okay, the weather underground.
The underground or the Met Service links. And I'm just wondering, is there one in New Zealand that works better with your sort of systems?
We don't access that information. There's a UK Met Office project that Met Service was party to, may still be, that sought to aggregate that information. I think the quality assurance and calibration issues associated with that information has meant it's hard to use it in engineering studies.
Okay. And this is maybe a question for you or a question for the staff. This is a really good project, understandably, for where you're looking for seeding and flood works, but it's also a really good project economically. If you're looking at people going out and spraying or anticipating what they can be doing in their work. And we did a back of an envelope exercise when the first one was, the Otago one was first looked at, and with the MPs in the Dunedin City Council once. And when you look at the savings you can make, or as we're looking at, not putting fertiliser on when you're about to get a really big storm coming through, there are some really other good ticks. And I'm just wondering whether we should be looking for more than just CDM as the reason to do this, and building a better case with our or if there's an opportunity to build a better case with our councils, their TAs.
I'm not sure if I could speak to the business case. In a science context, there's been a fair bit of work done in New Zealand around efficient application of fertiliser, including, I can't recall the name of the project, but NIWA and I think Landcare have had quite a big project that makes use of weather information. So it's certainly, not just the Otago region, but very interested in those optimizations.
And I would imagine ski fields would love some of this better stuff as well. So I don't know. I just think there's a bigger case to be built than just a science one. But
Any more questions for Luke? Councillor Ware.
Yeah, I was just wondering if you might be able to briefly touch on how hail and sleet and snow and stuff presumably complicate all of that even more.
Yeah, that's right. So rain radar is, we'll sort of go through those different hydrometeors. So rain radar has a notoriety, I suppose, for being quite terrible at snow measurements. I touched on, I suppose from a rain radar perspective, I touched on the problems associated with different drop size distributions, which we sort of refer to when we're thinking about liquid raindrops and the difficulties radar has in measuring them, measuring the total rainfall volume within those. The problem with snow is further compounded by the complex structures which snowflakes assume. There's I went to the European radar conference last year, and I was there's sort of 100 people, academics, working on measuring rain precipitation processes in the ice habitat with rain radar, because it's such a fascinating physical problem. But operationally, the radar struggles to do volumes of snowfall. It's something that's very difficult to measure. In terms of hail, the radar returns from hail are much larger than the equivalent liquid water drop would be, meaning that for older types of weather radar, there was a problem that hailing thunderstorms would come back as very, very strong returns in the radar data, and you'd get local overestimates of rainfall underneath hailing regions. The radar that Met Service have installed is a modern type of radar, which is equipped with a technology called Joule Doppler. Joule Doppler ameliorates some of these limitations by providing estimates of the relative width compared to the height of a falling drop, which can help identify hail and offset those errors.
Thank you, Councillor Somerville.
Thank you. Look, the second recommendation to this report is that we arrange for a letter to go to the relevant minister requesting weather radar coverage for Queenstown Lakes and Central Otago. Now, we've heard from Luke that the new installation at Hindon won't cover that area. So how important is that for us? And the fact that that's where an awful lot of rain falls, does that make that would that be particularly valuable to have an installation up that way too?
I think from a flood response perspective, definitely it is valuable. Luke has covered constraint about topography, but regardless of those constraints, I think we will gain much more spatial detailed information on rainfall pattern in areas such as Central Otago. We've got areas such as Roxburgh. We know that's really prone to debris flow, and those debris flow are triggered by very intense rainfall that can be very localized. So I think having a radar closer to that area will help try to identify those weather conditions that could create a debris flow, for example. So yeah, definitely will have value.
And again, pick up information that our rain gauges, more information that our rain gauges are able to pick up currently.
Yes. So the two systems works together.
Yeah. Thanks.
I would add that the nowcasting is very valuable for us in those urbanised areas, like we've noted in paragraph 8, where we have pluvial flooding risk, where rain falls on land and then causes an instantaneous flooding impact, and that's where we see the most value in terms of the nowcasting and the radar, whereas larger catchments, we will have quite a bit of time, many hours, on some places, days before rain becomes flow and before it arrives at that place, and that's why radar is so critical to us in the places where it's very flashy and heavily urbanised. And we know that this valuable radar for us in terms of Lindsay Creek and North East Valley and South Dunedin, but those other places, we still have a major gap there, hence our recommendation that we would like to see that filled. And also noting it takes time. The current radar, the decision the government made was in 2015. The funding for that became available in 2017, 2018, became operational at the end of 2020, and now in November 2023, 8 years on, we now see it being useful. So there's very long lead times to get this kind of thing in place. Which is why those decisions should ideally, from our point of view, be made early, so we have some certainty.
True. Yeah.
Perhaps a context as well, contextual comment to that about what else is happening around New Zealand. We've seen the comments in the media from the Mayor of Nelson about the need for another rain radar for the Tasman region. Similar issues are being grappled with in Auckland around adequacy of the coverage of a single radar for that region. That's in the absence of significant topography, just to do with the range limitations.
Just on costs, the number 10 in our paper, the $3 million radar installed by Met Service, that's a 2020 installation. We then go to costs because the financial considerations, we've got 120K. The cost of service for 2022-23 is 120,000, and then the annual cost is 69,000. So why is that so much less than what the Met Service paid? And
I didn't get why.
why is the indicated costs for doing a more inland Queenstown Central Otago installation so much less?
Yeah, I think to clarify, so the financial consideration cost, that's the cost of ORC paying to have the data from the radar processed to have quantitative rainfall information. It's not the cost of installing a new device.
Right. So we'd be asking central government to install the device that would be at their cost. And then the costs indicated here are purely to do with us
Processing the data to another step.
I see.
Yeah.
Right.
Yes, what we're doing is we're taking data that's available and then doing that further piece, and that's those costs there. Those aren't the cost of running a radar, the present one or a future radar. And of course, we're not the only users of it. As Lucas said, this is public information used by a whole range of people, and we just happen to be one user.
Cool. Yeah. Councillor Meppen.
Yeah, Luke, just a question around accuracy to forecast, which is probably a question accountants often ask. How do you go about that? What's the process involved in ensuring that you've got a level of accuracy that's really useful?
So this will be covered in a report that's yet to be finalised, where we'll which is part of that, actually that cost that's just been mentioned includes a commissioning report for the system. So that's not yet been prepared. In a more general sense, one does addresses the accuracy in a sort of a two-step process. So the first one is setting aside the nowcasting question, the accuracy of the radar estimates of current and past rainfall conditions are assessed. And that's done with a technique called independent cross-validation, where the radar results are compared with the council rain gauge results. So statistics about, for example, the root mean squared error will be prepared, and those will be available for council's engineering practitioners to make use of and refer to as an uncertainty estimate in their design calculations and so on, modelling activities. For nowcasting, a similar process is undertaken. So we have now an archive of radar information since December 2020. The radar hardware was commissioned. Of course, all that data has been retained. So what we will do is run the nowcasting in hindcast mode, so retrospectively, to generate all the forecasts that would have been issued had this system been operational. And then one using computers again does a comparison between the forecasts and the actual rain, which was subsequently measured to generate guidance. And statistics in this case are typically things like probability of detection, so the chance that you'll detect a particular high intensity rain feature, or a false alarm ratio, so how often the nowcast issues a warning about heavy rain that didn't come to pass. So that's the international best practice way of assessing a nowcasting system. So that information will become available to council's engineering practitioners in due course.
Very cool. Thank you. Another question, Councillor Wilson.
No, I'm happy to move with a slight amendment when it suits you, or I can ask a question of the chair, which may get rid of my need for my amendment.
However you want to handle it. All I was about to do, if there was no more questions, was just to highlight that we are noting this report. And then the second recommendation is that we are requesting the chair of Otago Civil Defence and Emergency Management Group to write to the relevant minister requesting weather radar coverage for Queenstown Lakes and Central Otago. So you're thinking an amendment to that?
Well, I would add a new 2 first, and that would be request the chair to take the proposal to the mayoral forum to support with the TAs to discuss or to raise the opportunity to support that action with the TAs, all the TAs. And there isn't.
I wonder if you're going to write as chair of Otago, I wonder whether it would be more appropriate to take it to civil defence group in the first instance, based on the request from this paper, which would effectively put it in front of them and get their endorsement.
Okay.
So that would be the process to give effect to what's currently in that recommendation.
Yeah, that seems sensible, yeah.
The problem is that that's a really narrow focus of CDM, where I think the issue that I'm trying to deal with is the economic benefits as well, and the environmental, which is greater than just CDM. And that's, I think it's getting more than just the CDM approach to it. I think there's a much bigger picture here that's a really good story. It would give a better case, that's all.
Should there be a separate letter from the chair of the ORC?
That's why I was going through the mayoral forum, but I'm happy to take your advice. They can do it through whichever mechanisms they like, but that's why I was going to ask the question of the chair, which way she thought the mayor, is there an economic, if there's an economic angle to this, should it go to the CDM or should it go to the mayoral forum?
I think it was intended to go to CDM, wasn't it?
Yes.
Well, we are very sure that there is a civil defence purpose to this, where we would need to do some work on the broader economics. So I think that that would be a separate conversation and may require some additional work. This is to get this moving for the purposes of civil defence, where we know there is a significant benefit to our ability to respond. It's up to you.
Seems to be a strong case for CDM.
Yeah, excellent.
Elliot.
Just a quick clarifying question. I'm assuming when we say relevant minister, we're meaning incoming, yet to be determined minister of the next government.
That would be the relevant
Yeah.
Right. Okay. What is the relevant ministry?
For the last state-owned enterprises, Met Service kind of thing, but it was written in this fashion because we don't actually
Okay.
know who it would be.
Okay.
And so, in terms of how they're going to structure themselves, so that's the significance of that. And I would just comment that in 2015, the chair of the Otago Civil Defence Emergency Management Group wrote a letter. At that time, government had made the decision to put the radar in, but it was going to be 2 years out. And so there is precedent for running it through the Civil Defence Group. My advice would be to do it through the Civil Defence Group. You might want to augment it with additional things through mayoral forum, but I would strongly recommend in the first instance to go through the group. It is an issue of public safety and property damage.
And a strong recommendation there. I'm conscious there is good intent in your suggestion. What do you want to do?
I think absolutely get all of that. What really pushed it over the line from me sitting in the DCC and seeing the MP support from it was also, it wasn't just one thing. You know, that would get it a really good return, but the even better return is if it can do both things. And that's where I want us to get right up the top of the end of the line of providing not just CDM response, but also a really good economic driver as to why you'll be putting it in. And that will put us up, hopefully up the ladder of getting that investment. That's all. I just think so I'm happy for this. I'm happy to add what I've suggested even as its third one, because it doesn't matter if it comes in from two directions.
Any other thoughts around the table?
Just still a little bit unclear. Sorry, what that one is. Sorry, I know your intent's really good, Kate. Just I would take it to mayoral forum to discuss then, or would I just write a letter, or what am I doing?
You take the proposal to the mayoral forum to raise as something they can support, as their economic development units can support.
So suggesting additional support to what is going to be written from CD.
Yeah. Honestly, don't worry. It's honestly too hard.
Yeah, we can, I'll be happy to do that. I'm sure it's something that everyone's interested in. Well, particularly Queenstown Lakes anyway. Yeah.
Yep.
Yep, happy to do that.
Okay, you're happy to do that. Should we leave the motions as they are?
Either or, yep.
So would you like a third motion added that chair is happy to raise?
Yep.
Yeah, no, I'll leave it.
Okay. Right, mover for the two recommendations, please, Councillor Somerville,
To move them as they are.
and seconded Councillor Weir. Thank you. Open it for discussion. All good?
I guess I'm just happy to say, look, that's really good to see that the installation of that radar, and it's enabling us to look after our people and our communities better. And with that recommendation to be saying, yes, we need this up in Queenstown Lakes, Central Otago to we will wish to be able to provide that service and look after those communities as well as we possibly can as well.
Great, thank you. Councillor
Just
Moon.
briefly, just picking up on Kate's point, I think potentially it has other benefits as well when you think about tourism and the Great Lakes in New Zealand, and particularly in the Fiordland, tail end of the West Coast, etc. Any additional service in this space could help in that regard. And it's a people safety thing. If it means that people who are involved in outdoor activities are better informed if they venture out there, so to speak.
Yes, anything that enhances is better. Any other comments?
I can make a quick point. I've missed quite a bit of it. I was really quite interested in this one.
Sorry,
You got there quite quickly, Gary, but no, I probably agree with the comments that Andrew and Carl said, but I think civil defence is definitely the place for it to go through, because at the end of the day, the civil defence Otago covers all of Otago, so it's getting input from everywhere. And I think the sooner you go through the path, that's the natural pathway for it, and the sooner you have it on the to-be minister's table, the better. And then behind there, you can create your support for it coming in behind. But if you were just to put another step in, all you're going to do is delay it and perhaps create confusion. So I think you're better to go with the recommendations and then create the supporting package ongoing.
Right, thank you. No other comments? We're good. Okay, I'll put the motion. All in favour?
Aye.
Against? That's carried. Thanks very much. Thanks very much for your presentation, Luke.
Thanks
Right.
for the opportunity to present. That's good. Thanks.
Thank you. So right, we'll move on to item 9.3, Clutha Delta Natural Hazards Adaptation. Again, team, let's just report as read, I assume.
Yeah, maybe just one line of introduction from me. It's the first time I think we present an adaptation plan to the committee around the Clutha Delta. We've talked in the past around individual natural hazards and how those can affect land use or infrastructure, but that's the first time where we kind of take this information and build a plan to respond to that. And the specificity of the Clutha Delta is a complex environment with different natural hazards, but also a heavy ORC involvement through infrastructure, so through the flood protection and drainage scheme. So we provide a level of service that modify the natural hazards. So that's why we put that program together. It's really to think about what the effect of those natural hazards are now and in the future on that area and on ORC infrastructure.
Right, thank you. Right, it's a noting report. There's a bit of detail in there. I'll open it up for questions. Councillor Weir.
Yeah, I was just wondering if you might be able to expand a little on sort of within the approaches where more nature-based solutions fit in relative to other solutions.
You mean in general?
Yeah, in the approach that is outlined. Yeah, like potential adaptation solutions to the
So
things outlined.
similar to other adaptation programs we talked about in the past, South Dunedin or Head of the Lake, for example, we'll be using the same framework, the Parrot, Protect, Adapt, Avoid, etc. I think for the Clutha Delta, for the moment, we are in that kind of first stages of the decision cycle about what the physical environment is.
So it hasn't been explored yet.
Not yet, but I think there is a good potential for nature-based solution given the physical characteristic with the coastal area.
So it's really it's setting a process to enable those kind of considerations to be brought in so that, as Jean-Luc says, there's some opportunities, if you like, in that coastal margin where the protection choices is a range from conventional, harder kind of engineered type things, maybe, to maybe some nature-based solutions, maybe. So everything would be in the mix in terms of that part of it.
To what extent with like scanned possible solutions and stuff yet? Okay, so
That's yet to come. But definitely in scope in terms of the thinking around, broad thinking around possibilities. Yeah.
Thank you. Any questions, Councillor Wilson?
Just going to the end of the document, we talk about communication considerations. This is a really interesting report, and it's about setting the work going forward. I get all of that. Sorry, paragraph 90. I said that. It doesn't. I totally appreciate trigger policy on significance and engagement, but I'm just wondering what the expectation is that the report comes here today. Do we just sit on the do we just accept it, or is there a promotion going to happen about it in media release? Or I'm just interested.
Mr. Chair, there's some planning to be some publicity around the report, as it often is with committee reports.
Mm-hmm. No, I mean that's great. I'm just hoping it is. These sort of start those conversations early, which is really, really important. And it's good to make sure that this information is especially pushed out things like the Clutha Leader. Yeah.
Yes, we've already met with Clutha District Council staff to talk about this piece of work and identified that we need to work together on communication and engagement planning.
Mm-hmm.
And as we noted in this paper, we will come up with a plan for how we both communicate and engage together on this work.
Thank you.
Great, thank you. Councillor Mepham and Councillor Somerville.
Yeah, really fascinating looking through some of the photos of floods that have happened before. It strikes me that Clutha is a place perhaps where a town should never have been built in the first place. But I'm interested also in the age of assets that you've got there, and the last significant engineering project that we were involved with there. What was it?
Do you mean in terms of construction of existing assets?
Yeah, the construction of existing assets in that area. Yeah.
I don't have that detail. It would be a long time ago. Michelle's on the call. She might have more knowledge around that question.
Yeah, hi. I hope you can hear me. I can't actually get my camera to work on Zoom. In terms of what the last infrastructure built and in terms of the current flood scheme, as we know, we don't have that information to hand. However, the last engineering kind of renewal works that we've been undertaking are certainly the flood repair work, and that's been around Riverbank Road and doing repair works as a result of flood events. But there hasn't been any new works, certainly in most recent times being the last 10 to 20 years.
Okay, so for me, it looks like the structures are aging structures. There hasn't been any significant engineering work done for that length of time. How desperate is it that we kick something off here?
I just want to qualify there, sorry, with no significant work done. Our maintenance program and repairs and inspections is part of continual work. So the state of the scheme is good, but in terms of how desperate Balclutha is, it's more a case of we've got coastal erosion that's advancing and it's starting to have an impact which we've already reported and alerted on. So we're now turning our minds to how we hold the line, particularly with the training line structure we have. And whilst we're examining what modifications or adaptation of our infrastructure might look like towards the coast, we will be also exploring nature-based solutions. And sorry, I didn't have a chance to chime in there before. I couldn't get Zoom working. You know, that's the interim process of what we're looking at. But for now, it's about holding the line on that infrastructure until we can assess what modifications look like.
Yeah, just can I carry on?
Yeah.
Just in terms of the modelling large rainfall events and risks around our current assets serving their purpose or not, is that something that's undertaken on a regular basis? Do we model flood scenarios against our assets there?
Yeah, so yes, we do that work around making sure the flood protection scheme or drainage scheme are achieving what they intend to do. The last time that work's been done for the Clutha was in 2005, and that was based on different flow scenarios coming from the stream and feeding into the scheme area, and trying really to make sure that, for example, the flood bank levels are still got enough capacity or freeboard to carry that different flows. Part of that adaptation, we're planning to repeat that study around how the scheme is going to perform under different flow scenarios, and also looking at the interaction with the sea and different sea level, both the river side and the sea. So
2005, so probably 18 years ago. So there's significant changes in well, I would think, in our expectations of floods and weather patterns since then. Is it something that we need to do sooner than later?
Yes, we do, and that's why we are doing that. We do quite a bit of simulation work on simulating how schemes perform under flood. And as part of this process, embedded in here is a review of the Lower Clutha scheme, how it performs. The bit we're placing more emphasis on now is how do schemes perform in over-design or super-design events. And that's something that hasn't been done, not a lot of that's been done in the past. How does a scheme perform in the probable maximum flood, the largest credible flood you could ever experience, even if it's very, very unlikely? What will happen? How will that scheme fail? And ensuring that the scheme will fail in a safe, predictable manner. And if it doesn't, how do you then re-engineer it in such a way that it doesn't provide full protection, but gives you enough time to effect evacuations and for it to collapse and fail in that predictable, safe manner? And that's where our thinking is going, and that's been the gap. And so that's what's being included in this piece of work and in our Lower Taieri scheme review. And so we're kicking off at the moment that assessment of that maximum or probable maximum flood, maximum credible event for key places across Otago. So that we've got up-to-date hydrology that informs that simulation work.
Right, thank you.
So when are we likely to see the result of that work?
Michelle, do you want to?
Yeah, so for the Clutha, that scoping is occurring for this annual plan. For the Taieri, we've had elements of that work happening where we're finalising the risk assessment and we're starting to look at that probable maximum flood event scenario. Just to go back to your comment around modelling, seems to be a long time since we've looked at it. Our frequency is to assess our schemes every 7 years or thereafter major events. So we're on track to actually start some of our condition assessments, and we undertake this as routinal maintenance works. Okay.
Cool, thanks, Michelle. Councillor Noon.
Thank you. My question was just around in paragraph 23 in when looking at a major flood event. And, we often hear about the QNEX where the river peaks. I was just interested to see the data here around the period of time that it remained in high flow. So I assume that, and this sort of comes from the perspective of adaptation and keeping the community informed about changes that we observe and the information we've got. I assume that we have got data around where those peak flows remain high for longer and longer periods of time in light of the type of rain events we're getting and the intensity of and the more regular. So we would have data that explain that sort of journey we're on to the general public.
Yeah, I think so. But in terms of data, we got a good length of flow records in Balclutha, and that's been capturing large flood event. 99 is an example. I think we've got also captured this 1978 event, which was another significant one, and more recently 2019. So we got a good record of flow resulting from different weather conditions, other headwaters, flooding, or lower catchment rocks brought down to the sea kind of responses, or a combined type of event. And part, I don't know if that's part of your question, but part of the information is also looking to climate change effect on those flows.
Yeah, and I suppose that, I get it with the peaks. It's really important, obviously, to understand that information, but that critically, the length of time that you remain in a peak, which creates, obviously, cumulative effects to whether it's infrastructure or people, risk of that risk to people living in low-lying areas. Because often it's human nature to think, oh, the rain stopped, we can relax now, blah, blah, blah. But if you've got high flows for the next 60 hours, it's still a significant risk that people need to be mindful of. But it was more around tracking what's happened in the past so we can share that information. So probably just to help the story about an adaptation journey.
And for relatively recent event, we've got that, like, I don't remember when the Clutha recorder was put in place. Maybe Tim remembered that, but it's about in the 60s.
If you have a look at figure 1, that shows the full record for river flows at Balclutha, and that's back to late 1954.
And that's continuous recording. So not only recording peak flow, but the full flow.
So, awesome. Thank you.
That was actually, I was going to highlight figure 1 as possibly one of the more interesting, not that the rest of it isn't interesting, but one that gave a real picture of the track history between 1955 and through into current time. So when you look, if with your indulgence, Councillor Robertson, because you were next, so just the questions I was going to ask around figure 1 now that we're at it, is around the, we have about 1 point something metres of freeboard to crest level, and then we've got events in relatively equal time periods. We've got quite a density down at the lower level of the flood bank, and then these challenging events. There's 4 major ones there, and then some less major ones. But we're still left with that 1 point something metres of freeboard. So then the level of comfort that flood bank is providing us, given that we're up at the more danger zone of the flood bank, we're not up at crest level, but we're close. And of course, in those events, as Councillor Noon has highlighted, we've got far greater volumes challenging the weaker part of the flood bank. So, I mean, is that figure giving us comfort that these events aren't getting higher up the flood bank, but the flood bank is still aging?
You'd need to do the statistical analysis on the size of floods to get a sense of whether they're becoming more frequent, if you like. It's true that this graph shows there's quite a bit of freeboard, but on the other hand, it still means there's quite a lot of water being retained by the flood bank, and as Councillor Nunes said, one of the characteristics of this place is that water stays up for a very long period of time. And so whilst the failure by overtopping, you might be comfortable about that, the longer that you have high flows, you're more likely going to have a seepage path developing under the flood bank foundation, which then increases, say, the piping risk. And so you could very well have a weak spot that will fail structurally, even if there's still quite a bit of freeboard at that location. And that's actually a more complex, difficult thing to deal with because you cannot see it happening. And so that is quite a bit of our program of scheme management is around trying to manage that failure mode in addition to the overtopping one. Michelle probably has some comment to add too, I think.
Yes, go for it, Michelle.
Hi, I just wanted to add, and I'm sorry about the background noise, unfortunately. I just wanted to add to your question, Councillor Noon, and some of the good conversation around the table around it's about that duration of holding floodwaters. What we're doing with the Tyree, particularly around Outram, and we're including in the scoping for Balclutha, is certainly the trigger level assessment. And that looks at the factor of safety around flood banks and durations of saturation in terms of how long those levels are sustained for. So we've recognised that. That's an important consideration in terms of our modelling, and also, thresholds and trigger levels that we make decisions around with emergency management and ourselves in terms of the state of our flood banks. So that work is currently being scoped and is kicking off at Outram as well.
Okay, great. Thank you, Councillor.
Thank you. You asked my question in another way from how I was going to ask it, so that was great. I was just trying to understand the risk of a super event, I suppose, but we need to do the analysis by the sounds of it to understand all of the components of risk. And there's rainfall, but then I guess there's other things upstream around earthquakes and landslips and all sorts of other things that could be part of the risk setting as well that we just need to understand. Sorry, it's not a question now because I already had it answered. Thank you.
Right, thank you. Councillor Somerville, Councillor.
Thank you. Thanks. Look, I'm just looking at the next steps, and in particular in section 92, the high level timeline. And look, so I can see this is shaping up as a large and important project. When can this committee expect to hear more about this? It might be that scoping completed the end of this year, I guess.
Yes, I'm anticipating that we would be able to be bringing an update to the next meeting of this committee. It's a bit like the Headlight Wakatipu thing. The pace at which it's happening and the range of things that are being worked on means that it's with an update at least at the next one, and probably one at every committee potentially after that.
Great, thank you.
Okay, thank you. Right, have got any questions?
I've got a question.
You've got a question? Go for it.
I've got 2 or 3 questions. The very first question was just around that. So I've gone off now around that table 7, table 1. So the freeboard at the top, while we talk about the meters, have you got any idea what that is in flow rate? Because that's why my head thinks. Because I understand all the other risks, but the initial flash bang, we need to know how much the whole thing can hold. Because you got your best floods, I think the best ones are up around the 4,000 cubics. So it looks to me like the flood bank might be at 6 or 1,000 or better even. I don't know.
Yeah, that's pretty good actually. Figure 3 is probably the relevant one. That's the one that's got the scheme design standards. And so, as you alluded to, 5,600 cubics plus 300 freeboard is the design standard for Balclutha. Figure 3, page 215. But that's to be tested with the modelling. What is the protection today and in the future?
Yes.
Yeah.
Yes.
Catchment modelling as per at design time versus catchment modelling now with changes of land use and
correct.
Could make a difference.
Ended up with the wonky Well, no, there was one was number 15. I was just going to follow up on what Kate was saying before as well around the communications of the report, because we're sitting here with a report around the lower Clutha flood scheme with some, pretty grunty stuff. And I was just wondering, where our communication, you mentioned that in talking with Clutha District Council, but has there been any direct conversation with the landowners, the affected parties?
Not at a broader level, but there has been some targeted discussion in respect to some of the current issues that we've got at the minute. Michelle might like to speak to that.
Okay, thank you. Yes, we've been certainly speaking at a scheme level, particularly with the drainage infrastructure landowners, and our team does that regularly and consistently. But in terms of a broader all-in community, we haven't organised that yet as a team, and we're probably looking to do that with other functions, not just our part of our BAU interaction.
Yeah, I guess my feeling is if I was a farmer down on the deltas, and I'd be quite nervous having read this report if I wasn't aware of the report up till now, just to comment. Another one, the section 15, I found it now, is I was just wanting to try and dig a little bit into the effects of the dam. So you say that because of the Clyde dams, that you're getting a 95% reduction of sediment coming down to the delta. Now, I'm just struggling to understand what that effect is for the sediment not coming down, because if it was coming down, I'd be expecting the delta to be building up, but that may not be the case. I don't know what the story is there with the geography. Well, John.
Yeah, I could try that one. So yeah, any change or reduction in the flow of sediment through a catchment will lead to a reduction in the bed level of the river as that sediment moves through and out to the coast, and that is what has happened. But both due to the dams, but also earlier there was a large pulse of sediment introduced into the river system through alluvial mining, and then as that source reduced, there's also a natural reduction in the riverbed levels. And in terms of whether the delta has been building up or not, we've had some geological studies and age dating of sediments, which has shown that the level of the delta has stayed relatively stable through the geological history, the last 6,000 or 7,000 years. It's more, everything's staying largely in balance.
So, but yeah, they can't follow up a few questions. So does that mean I'm sort of talking more about at the Carwell mouth, at the mouth? So because there's not that sediment coming down, is that affecting what's happening at the mouth?
Yes, it's been identified as one factor. So not the only factor. So things like the alignment and construction of the training line itself has also had an effect on sediment dynamics in that coastal environment.
Yeah. Sweet. I know whether some sediment needs removed, probably perhaps not for the dam. I was just trying to get my head around that because that is quite a big thing. And so, but I understand Contact, they pay towards work down at the mouth as well. Is that correct?
Yeah.
Part of the consents.
Part of the consents is that there's a contribution to works at the mouth. Yeah.
Yeah. Another one's just a note I had, number 70, and I think that was just around, once again, communication around, and it was around communicating with Okaha, and I was just wondering also whether we're communicating with Te Ao Marama and Hopunui Runanga, because they both would have interests in that area.
Yes, I'm not familiar if we've done that already.
We have, yeah, but we have plans to do that, yes. Yeah.
Yeah.
So we're scoping out our engagement plan. In that area.
Yeah, I just think, yeah, at the end of the day, this 58 through to 63 is quite, at the end of the day, it's quite, particularly 63 at the end is like having a whole new change of approach. Like investigating a whole new change of approach is probably the thing, and obviously it's something that we need to do. It's just our approach with our community to make sure they're on board with us as we right at the very beginning, right at the very first leaf. Yeah.
Fair points. Okay, great, thank you. No more questions. Elliot, you were indicating you are happy to move.
Move.
Thank you. Is there a second for noting our report?
Seconded, Mr. Chair.
Councillor Noon, thank you. Have we got any discussion? Any further discussion? No. Okay.
I'll speak to it.
Oh, sorry. Go ahead.
You're first if you want, unless you want to go second.
Don't mind either way. Just think it's worth recognizing obviously even though the acceleration of severity and scale and frequency of climate related events are pretty unprecedented, the issues themselves aren't entirely new. So I think it's like worth reflecting on places like Port Molyneux that 150 years ago or something went from bustling town to, well, not that. And it'll be valuable to reflect and even compare how those issues 150 years ago in the same area and how we go about addressing them now as a council and a community, both in terms of our technological ability to predict and adapt and stuff, as well as our actual plans for how we do go about responding to these hazards might differ and might stay the same, including how proactive we are now, with hundreds of years of history to learn from.
Thank you.
Just really briefly to say that, this is going to be a really significant project for our council. We've got major settlements in the lower part of this catchment, conveniently located next to the river, which is a massive beast. And as we can see there from the flood peaks, the power in that is phenomenal. We have been doing a great job of maintaining the assets. But we've got some real issues with particularly shoreline retreat going forward. With mapping the history of how rapidly that's progressing, and then that'll only speed up into the future with sea level rise as well. So it's an issue that we are really worried about, but also need to work through sensitively with those communities and with our eyes wide open. And that's what we're doing here, along with other places like Glenorchy and South Dunedin, and taking that adaptive, dynamic adaptive pathways approach, and also working really, really closely with the TAs. So building that relationship with Clutha District Councils and just working really closely is really important. So this is it's not a first step because you've been doing a lot of work in this area already, but we're on a journey, and the journey does not stop because this is an incredibly important issue. So a lot of confidence though that we have got fantastic staff and also specialists that work with community on adaptation too, should any of that be needed. So really we're set up really well to be able to have those conversations. Thanks.
Great, thank you. Mr. Chair, Councillor, I think Councillor McCall, yes, then you want to speak to?
Thank you, Chair. No, I just wanted to say you got to be really careful with these ones if we start comparing what it was like in the 1950s and rivers changed and it didn't, we didn't think too much about it. In the ensuing 80 odd years or however many years it is, people have shifted people have been encouraged and have shifted into the area, being encouraged with the safety of the man-made structures that are protecting the land. And they've been encouraged to move into those areas. So you don't want to take the people who are living on the ground for granted, because at the end of the day, they were provided the protection and they went there and they shifted there. It's not like the river came to them. The river was held up by people so they could move there and encouraged to move there. So this is why it's so important that you actually have to deal with those people to start with, because I've thought that they're actually generational properties in there. It's their businesses, it's their livelihoods, it's their families. So we have to respect that at all times and make sure that they're involved right from the very beginning. So please don't minimise the effects to the individuals in the area. And I think so. That's why, to me, we have to make sure that every person who's affected gets an opportunity to partake. I do believe that we have to understand that we cannot control nature forever, and there's times where we have to try and there may be times when we actually have to change our tactic, you could say, from protection to adaptation. But it's something that's going to take over time. But we got to make sure, as I say, don't. It's not just the wild west out of the bottom of the Clutha River. It's actually people there, and so we got to treat them with respect. Thank you.
Councillor Moore.
Pick up on the Wild West. I think it's important that we don't scare the horses. I think this is it is a delicate process, but I think we also, as an asset owner, we are doing the right thing to ensure that stakeholders, people that live there, own land there, live in adjacent residential areas, are well informed about what we believe is the future, and I don't know what it is, but our decisions will be based on well-informed, robust science, and I think we need to, and others have already said that we need to take the community along with us, but I think fundamentally we have the responsibility as an asset owner to carry out some clear messaging once we're well informed ourselves. But let's not scare the horses at this stage. Okay, and there's been farming in that Paratai and the rest of that delta, the Clutha Delta, the last 170 plus years, and obviously landowners have had to adapt from time to time in those significant flood events, and whether it's affected residential activity or their pastoral farming activity, that sort of thing. You can only adapt for so long, I suppose, and we acknowledge that, but yeah, let's not scare the horses.
No, I think that will be the sentiment I would be coming from too, that this is about, we have an asset, we manage it, own it, maintain it, and we're highlighting concerns that we see into the future, and some of them are very there to be seen right now. We've got repairs and maintenance that we are doing, and then there's predictions into the future, and who knows what the end outcome could be, but it's important that we do highlight those issues as we learn about them, and but not jump to any conclusions that then, as you say, could absolutely have the horses bolting. We aren't in that space of it at all. So anyway, is there any other comments? Okay, thank you. I think it's been a good paper and a good discussion, and I'll put the motion. All those in favour?
Aye.
Against? That's carried. Thank you. We'll close the meeting. Councillor Somerville, would you like to do a closing karakia, please?
Thank you. Thank you. Kia tau te rangamārie ki runga I ngā iwi o te awa. Peace reign on all the peoples.
Thank you very much. Thanks, everyone.